All right, Algebra 1, let's do a little bit of trig, okay? So, lesson 11.5, trig ratios. So a saying that we always use when dealing with trig is Sohcahtoa. Sohcahtoa. This symbol right here is called theta. It means degree measure. Okay, so to define what sine is, the ratios. So how Sohcahtoa works. Sine, that's the S for sine. O stands for opposite. So sine is opposite over the H in a right triangle stands for hypotenuse. Okay, cosine. The A stands for adjacent. Again, the H stands for hypotenuse. Tangent, the T. O stands for opposite. A stands for adjacent. So, sine of theta is opposite over hypotenuse. Opposite over hypotenuse. Cosine of theta, adjacent over hypotenuse. So adjacent over hypotenuse. Tangent of theta, opposite over adjacent. Opposite over adjacent. Okay, so that's how those work. So let's say I want to find the sine of A. My sine of A ratio, and my tan of A ratio, and my cosine of A ratio. Here's A. So right in here, I'm going to place my little theta, just so I know what I'm kind of looking for. So according to A, I always first label the hypotenuse. You know, that's the longest side, the side across from that right angle. So that's my hypotenuse. Okay, and I'm just going to abbreviate. So that's my hypotenuse. According to this piece next to it, so if you are adjacent to something, that means you're next to it. So the 4 would be adjacent. And across from it would have to be my opposite. So let's find the ratio. Sine of A, opposite over hypotenuse. So it's 3/5. Cosine of A, adjacent over hypotenuse. That's 4/5. Tangent of A, opposite over adjacent. 3/4. So what I would do when I'm doing these is I would label my points according to what you're looking for, or wherever your theta is that you're looking for. Label it. Okay, if I was at B, so let's just do a what if I was looking for B. So here would be my theta for B. Do it in a different color. So let's say I wanted to find my sine of B, my cosine of B, my tangent of B. Hypotenuse is never going to change. That stays as the hypotenuse. But now, according to this data, 3 would now be my adjacent side. This would be my opposite side. So sine is opposite over hypotenuse. This, opposite over hypotenuse. So it would be 4/5. Cosine, adjacent over hypotenuse, 3/5. Tangent, opposite over adjacent, 4/3. Okay, so that's just how to find basic ratios. Okay, which is pretty easy. So move over here. Calculator. Let's say I want to find the sine of 70. So I'm going to take out a calculator. Again, any calculator will work. I just happen to have this one here. So I'm going to take out my calculator. All calculators have your trig functions. Sine, cosine, tangent. I know you guys have probably seen those and probably wondered what they were many, many years ago. Those are your trigs. So, first thing I want to make sure, okay, your calculator has to be in degree mode. For those that have just regular calculators, it should say DEG or D up in the corner. Okay, so this one here, I'm going to change it. Mode, I'm going to just check it. So I've got radian, degree. I want to make sure it stays in that degree mode. So notice it's highlighted, so I don't have to change it. If I needed to change it, so let's say it looked like this, and I needed to change it, I would just move my cursor over, hit enter, and make sure it was highlighted. Okay, so we're going to quit out of there. So now you just type in sine 70. Enter. And you should get 0.9396 or 0.9397. Make sure you round that up. Okay? So that's how you use that calculator. Okay, we're going to be doing a lot more calculator work here in just a second. So let's say I need to find the value. I want to find x in all of these. Okay, so I'm going to find x. So I look at this, I have my 11 degrees. I'm not going to ever go off my 90 degrees. I go off my 11 degrees, the other degrees that they give you. And so according to this 11, we know that this is your hypotenuse. This is adjacent because it's next to it. This is opposite because it's across from it. So now we've got our Sohcahtoa. We're looking for opposite over adjacent because that's what we are given. We're not given hypotenuse and we're not trying to find the hypotenuse at all. Okay, so we're given opposite over adjacent. Opposite over adjacent, that would be my tangent function. So I would write this as my tangent of theta is opposite over adjacent. So when I write it out, I'd have tangent of 11 equals x over 3. When two proportions are set equal to each other, so now we got to remember, when two proportions are set equal to each other, we cross multiply to solve. So this is basically sitting over 1. So you're taking x times 1, which is x, equals 3 times tan 11. So now in your calculator, we've already have it in degree mode, so you don't ever have to change that again once you have it in there. So we need to do 3 tan 11. Close the parentheses, hit enter. So that means that that side is going to be 0.58. So x equals, which is a very small side, it's only half of a side, x equals 0.58. Okay? So let's look at another one. Let's look at this next one. So we got 27 degrees here. According to 27 degrees, so there's my right angle. That makes this the hypotenuse. And that makes this the opposite. So what is opposite over hypotenuse? Opposite over hypotenuse. So what function is that? Sine. So you would go sine 27 equals opposite over hypotenuse. Cross multiply. So stick that over 1. 1 times 4 is 4 equals x times sine 27, x sine 27. Okay, now people always ask, what do we do to get x by itself? Instead of multiplying 4 times sine, I'm going to divide. So I'm going to take 4 divided by sine 27 equals x. Okay, so in your calculator, 4 divided by sine 27. And you get 8.8. So x equals 8.8. Okay, let's do one more. So this one up here, you got your 15 degrees. So label everything. You know across from the right angle is your hypotenuse. This is 15. That's adjacent to it, so that's your adjacent angle. So adjacent over hypotenuse, look at that, cosine. So I would say cosine of 15, my angle, equals x over 14. Cross multiply. So get over 1. 1 times x is x equals 14 times cosine 15, 14 cosine 15. Calculator, 14 cosine 15, close parentheses, enter, 13.5. X equals 13.5. So there's your introduction to trig. A lot of people love trig. A lot of my upperclassmen love the basic trig stuff because it isn't really that difficult. And now you guys are getting your very first initial, so you guys are going to see trig long before they ever saw trig, which is pretty dang cool. So you're getting your very first initial aspect of what trig looks like to finish out some standards. Okay, to help you get ready for a lot of those tests that you have to take, your maps and stuff like that. So there's the very first start of trig ratios. Like I said, kids love it. Remember Sohcahtoa? Okay, that's a saying you're going to hear every single year. You're going to be doing this every single year. Okay, so trig is very important. Trig is actually pretty cool. And when we do the story problems tomorrow, you will see how we can put trig into place and how we can find the measures of the stuff using trig. So people use trig all the time. So there it is, lesson 11.5, trigonometric ratios.